Microsoft Ignite.
Next up, a segment for the gamers. But first, do you know what game intelligence is, or Project Paidia? How about reinforcement learning? In this Tech Minute, join researcher Dr. Katja Hoffman, principal researcher at Microsoft Research in Cambridge and lead of game intelligence team, as she gives us an exclusive behind-the-scenes look at Project Paidia and how they are pushing the boundaries of human AI collaboration through deep reinforcement learning. Take a look.
Hi, my name is Katja Hoffmann, and I'm a principal researcher at Microsoft Research in Cambridge, as well as lead of the game intelligence team. My team and I advance the state-of-the-art in reinforcement learning, driven by current and future applications in video games. Our long-term goal is to develop AI systems that are able to learn to genuinely collaborate with people, to empower their users, and help solve complex long-term challenges. But what is Project Paidia? Project Paidia is a research collaboration between my team here at Microsoft Research in Cambridge and Ninja Theory. The focus on our collaboration is to understand how we can develop AI agents that learn to genuinely collaborate with human players, in this case, in a team-based game. What is reinforcement learning? To start, let's look at an interactive demo. To try out this interactive demo, simply go to the AI innovation page on the Project Paidia deep dive and click on the interactive experience. This is a demo of a little game that we designed to very quickly test out how agents can learn to collaborate with human players. In this game, you control one character, the little robot in white, and the trained reinforcement learning agent controls the second character, shown in blue. The goal of the game is to collaborate in such a way that you, the human player, is able to escape from the spaceship shown here. In order to do this, one player needs to activate a switch so that another player can visit the two platforms that unlock the door. So let's take a look at how reinforcement learning works in an interactive game like this. In reinforcement learning, we model an agent, so for example here the robot character in blue, as being embedded in some environment, in this case the game world. The agent observes aspects of its environment, and this is called an observation. For example, in this game here, the agent may observe its relative distance from the two switches and from the other player. The agent can interact with its environment by taking so-called actions. So in this case, that can be just moving left, right, and forward. In other games, that could also be jump, attack, etc. By taking actions in this environment, the agent actually changes the world. And in reinforcement learning, the key goal is to learn about how the agent's actions affect the environment and eventually lead to positive outcomes. These outcomes are formulated in terms of a reward signal. So for example, in this game, you could imagine that the agent gets a positive reward whenever its teammate manages to escape the room. And in reinforcement learning, the key machine learning algorithm is all about learning about how the actions that the agent takes in a sequence lead up to positive or negative long-term consequences, such that in the future, the agent is able to maximize its chances of getting positive outcomes and minimize the chances of getting a negative outcome. So just to develop a little bit more intuition on how a reinforcement learning agent can actually work out the consequences of its actions, we can look at one example technique that is called bootstrapping. When using bootstrapping, a reinforcement learning agent would consider both the reward that it observed for as an immediate outcome of taking an action in a given game situation. And it would also take into account its current estimate of the quality of the situation that it ended up in. So for example, if I get an immediate very high reward, but I end up in a situation where I'm stuck, let's say between two walls, that wouldn't be a situation with good long-term consequences, and the agent would learn to avoid that kind of situation in the future. So using reinforcement learning, agents can learn very natural, nuanced behavior that comes out of directly interacting with the game environment or another application environment and working out long-term consequences due to the pressures of that environment. Now, if you look at the demo here, we have actually trained this by putting the agent in a wide range of different game situations. For example, randomizing the positions of the switches, and also the starting position of the agent, so that the agent has gathered a lot of data of how it can interact in those different scenarios. So let's take a look at what this actually looks like in the game. You can see in the demo here that the trained reinforcement learning agent initially goes towards the red switch, but as it notices that the human player is getting closer, it changes its tactic and lets the human player flip the switch while it visits the platforms and activates the door. This is not just a simple video. You can actually directly interact with this and control the character in white. As mentioned before, Project Paidia is all about developing AI agents that learn to collaborate with human players, not just in the demo that we saw here, but in modern complex video games. And as it happened, a game developed by Ninja Theory called Bleeding Edge turned out to be the perfect testbed for this research. In this demo here, you can see the tank Buttercup, shown in green, taking on several of her opponents. She can do this because the healer, Zero Cool, and shown in red, is there to back her up. So this is an example how our agents have already learned to effectively collaborate to achieve the team's overall goals. Our ongoing work with Ninja Theory drives our research in reinforcement learning with the goal of developing agents that learn to collaborate with human players. You can read about all this and our ongoing research on our latest research blog. Beyond driving the state-of-the-art in reinforcement learning, my team and I have the goal to democratize reinforcement learning to ensure that in the future, every developer has the ability to use these technologies, either to create better game experiences or for other real-world applications. In order to achieve this, we have closely collaborated with the team at Azure ML in order to bring reinforcement learning-based samples to you. By trying out reinforcement learning on Azure ML, developers can focus on the basics of really training the reinforcement learning agent, monitoring its performance, and seeing results quickly. So to try out reinforcement learning on Azure ML today, go to the link shown here in the video. On there, you will find one sample notebook that showcases learning to collaborate in what is called a particle environment. In this environment, you will see a simplified version of the escape game that we showed you here on the Project Paidia demo. And you will see how you can train your first agents to learn to collaborate to solve a task. So try that today. To learn more about this project, visit the following websites. The AI innovation page on Project Paidia, which includes the cool demo that we showed you earlier in this video. My groups page, the game intelligence team, as well as our latest research blog. And visit the Azure ML samples of how to train your own reinforcement learning agents today on the Azure GitHub pages, as well as the Azure site. Thank you for watching.
Let's visit one of our featured partners, Quest. Take a look.
The next